right, so this is talk about building robust APIs with Python. We're going to look at what drives me personally to spend so much time and focus into designing and building robust APIs, what robust APIs are, and how you can do them as well. It all started back when I was in college and Intel was still a very young consulting agency. I read about a famous Slovenian entrepreneur businessman, how he spends half a year in Slovenia and then the remaining half a year in Brazil kitesurfing on a beach. One day, I thought to myself, one day. And really, I couldn't get that thought out of my head. And then I came to a realization that there's not really anything preventing me from doing it. And at Nitel, we had international clients, many of you in this room, and you didn't care where I'm located as long as the work was done. So I did. Spent my first winter in Spain. Terribly sorry, meant Catalonia. It was a total blast, spending my mornings working at a sailing club in Barcelona and afternoons on the water. And when it was time to go back home, I was convinced that I really have to do this again. So I did. When it got properly depressing the next winter in Slovenia, as it does. I don't really mind the cold and the snow, but I hate it when it's like somewhere in between. It's just foggy and rainy and slush instead of snow. This is what I don't take well. So packed up my car, headed south to Valencia, had a blast. And I've been escaping winter ever since. You know what sucks though? Like I need like a week to pack everything into my car, all the baby stuff and all our family into the car. It takes me a week and 2 ferries and 4,000 kilometers to come to Canary Islands where we stayed these years. And finally I come to the beach, the waves are pumping, the sun's out, the wind's howling, it's perfect. And then this happens. I'm getting called in because we have a production issue. And one of our VIP customers is calling in that our API suddenly started returning a different result and we didn't notice and we broke their integration code or we broke the front end. Or maybe our app is crashing because the view code is trying to process some invalid data and why do we even have invalid data in our view code? So that is my why. I really, really don't like people breaking my schedule. Let's continue with the Plone API story. My first proper dive into designing APIs was 7 years ago on a Plone conference in Munich. We started the Plone API project on the after-conference sprints, and I got my first experience, really about everything that is hard with APIs. So the project started, Plone API started because back then Plone was already 10 years old, and it required memorizing a bunch of boilerplate code for very mundane tasks, such as just getting a freaking site URL. And we had this idea; it should be like really, you could just write it from your memory, give me the URL. And the same thing for moving an object, which is like just content.move and not some strange 2 lines magical incantation. Review state, exactly the same. And so what we did essentially back then was survey a bunch of Plone integration code that we all had on our laptops. And we identified 20% of the tasks that people do 80% of the time. We put them down on a piece of paper, like those tasks, and then went through them again and again and again to figure out what's the best way of naming them. And we wanted an API that is easy to remember and especially easy to guess. And then we wrote documentation for how people are going to use this new API methods that we came up with. And by writing the docs, we really polished the naming of the API methods. And this might sound trivial, but naming is one of the hardest things to do in programming, especially when you're designing APIs, because once you have an API in production and users already wrote code to integrate with your API, good luck changing your methods name then. You're just going to cause a ton of pain and suffering. By the way, these snippets of documentation were and still are tests. These bits of code are run on every commit, which makes sure that when a pull request comes in, that the pull request does not change the signature of the API, because if it would, those tests would fail. So yeah, Plone API, super successful. over 60 contributors over the years. People have given talks about it. It now ships with Plone Core, and I haven't touched it in years, so great success. The big lessons learned with Plone API, at least for me, were that always write API specs before you write code. Like we really sat down for a number of days, and then again after a couple of months to just to write down how the API is going to look, and to write the documentation how the people will use the API to really give us a clear idea of what we want to do before we wrote the first line of Python. And yeah, but then it turns out if you want to do microservices, web API, RESTful web services these days, you don't have to really look far for how to do documentation. Use Swagger, which is today basically the de facto tool for describing REST APIs. You do a YAML specification, and then that generates nice HTML documentation with an integrated test client. So like this is all automatically generated for any endpoint. You can see where it is in the YAML file, and then you can click try it out to basically exercise your API through the browser, so you don't have to do any client code to see that your API is working. You can copy the command as a CRL in your terminal if you want, and then here you see the response that you got back from the API. And this is super nice for your users because documentation is fine, but if you don't have really good examples, it's going to be really hard to integrate with your API. But if you give this to your integrators, like they can just copy the CRL into their terminal, and then from that infer how they want to build their requests. So this is super nice. And then the ecosystem, the whole ecosystem around Swagger is fantastic. They built a lot of tools such as client generation tools. There's a tool that you can give it any YAML specification for for this Swagger YAML, and it will generate a Python class that will have like methods for connecting to each of the endpoint on the API, so you don't have to manually like type requests.get or request.post. You just call the function with the appropriate parameters, and they have the same for React and general JavaScript. So there's a lot of boilerplate code that you don't need to write anymore if you use Swagger. But then again, when I say Swagger, I actually mean OpenAPI. So Swagger was it first released in 2011. Then there was Swagger 2, and recently, a couple of years back, they started working on Swagger 3. At which point, Swagger is a company. It didn't want to have this. There's a company behind the idea, so they made a foundation called OpenAPI Foundation, and then transferred all the intellectual property to this foundation, and also changed the name of the specification document from Swagger to OpenAPI. So whenever I say OpenAPI v3 or OpenAPI, if you're used to Swagger, you can just mentally replace that word to Swagger in your heads, right? Now you know why to do robust APIs. And now you also know what makes an API robust, and that is always up-to-date, automatically up-to-date documentation that can never be wrong, and signature of the API that does not change without intent. Meaning, if you push some code to master to production, that the responses from your API or the input validation for your API does not change unless you really wanted it to change. So that you don't, change for example, if you have users integrated into your API with their custom code, so that you don't change the API under their feet. Right. Last summer we started working on a new project called WooCart. It's a complete autopilot hosting for web shops built on top of WordPress and WooCommerce. And I was in charge of building the API that will glue together the client-facing control panel built with React with the deployment machinery in Kubernetes. And using Python was a natural technology to use as that glue. So the idea is when a client wants to deploy a new store, they log into this React web app. They click a button, they wait a couple of minutes. Python sends the correct API requests to Kubernetes, waits for Kubernetes to do its magic, and then reports back to React that the app is successfully deployed and displayed the new app. So basically, I went to the OpenAPI website, and I wanted to see what Python integration libraries exist out there for OpenAPI. And I was quite bummed out because this looks very much like choosing a JavaScript package. There's a bunch of packages with similar names and a lot of overlapping features, and at least in the beginning it looked like it's going to be really hard to decide which one of these I want to use. But then I really was quite sure that I want to use Pyramid because I wanted to build a robust API and so I can go surfing, and Pyramid is really a mature, if not the most mature web framework out there. It allows you to start small in a single file if you want, and then scale with you as you go. And moreover, at that point, it got known that the people that rewrote and relaunched pypi.org, they used Pyramid to do it. So they're one of the most knowledgeable people in the Python community. Plus, pypi.org gets a lot of traffic. So if Pyramid is good for them, then it's probably good for me. Still down to 6 packages. Growing up, I was a huge fan of Mythbusters. Anyone here fan of Mythbusters? Yay! I really loved watching Adam and Jamie bust one myth after the other, and I consider myself to this day a tinkerer and maker. And really, I'm always hunting for some free time so I can do some DIY projects. And you can imagine my joy when I realized that Adam's first book came out recently. And it's called Every Tool's a Hammer. It's kind of an autobiography mixed with a collection of tips on how to be a good maker, how to be creative. And like besides the main title of the book, which is Every Tool's a Hammer, which is a good reminder that if you're really good with one tool, then you see all the problems in a way that how you're going to solve it with this tool, and you don't always consider other options, which is what happened with me with traversal. I was so into traversal that everything I looked at was like, this is a good traversal problem. But then I tried to do URL dispatch for about 2 years. I'm like, yeah, maybe a lot of problems are more suitable for URL dispatch. Anyhow, one of the main chapters in the book was use more cooling liquid, which is kind of strange. And then also Adam was in a podcast, and the podcast interviewer asked Adam, what would you tell your 25-year-old self? Like, what wisdom would you give to your younger self? And Adam said, use more cooling liquid, which is kind of strange advice, don't you think, for to give to a 25-year-old? But the idea here is that it's not the act of applying cooling liquid when you're drilling a hole or cutting some metal. The idea is to remember yourself or himself to think before you cut or think before you drill. To go slow. It's about preparation, like really putting in the mental process and the mental thinking before starting the work. And I realize this really applies to how you approach APIs. Because there are actually 2 distinct approaches to how you can do OpenAPI with web frameworks. There's the generation approach, and there's the validation approach. So the generation approach looks like this. You write a bunch of Python code, models and views, and then you run a command, or maybe it happens on the fly, and then you generate the YAML file out of your Python code. And the first time you do this, it's absolutely amazing. You're like, this is going to change the world. And it's super cool. You just write some Python code, boom, YAML specification, boom, documentation, everything done, I can go home. But then there's the validation approach, also called the API first approach, which is you sit down, you think about how your user is going to use your API and how your API is going to look like, and you write that down in a YAML file. And only then, when that is done, the documentation is complete. You go through the documentation, show it to some users. They say, yeah, this looks great. Only then you start writing Python code. And then finally, you validate that your Python code does whatever the YAML file says it should do. So this validation approach incentivizes you to write specification so that all of your developers can understand what your API does before you start writing the code, and it really provides a clear separation between intent and implementation. Because if you start specifying your API by writing code, you're going to be limited to being in that mindset of I'm going to write this and this and that, and then that's going to generate my API. You're going to be much better at designing APIs if you forget about the code for the first. Just forget about the code. You're able to do anything, so forget about the code. Just think about how the users will feel and how they will use your API. Then there's the fact that generation and validation approaches are both always going to be imperfect because we live in an imperfect world. So here's an example of a same bug in a, on the left, a generation library, and on the right, a validation library. So the bug is that OpenAPI specification supports polymorphism. Doesn't matter what that means, but both of these frameworks or libraries didn't have polymorphism. And in a generation, but at the same time, the client generation tool for React had polymorphism. And this is exactly what happened to us. If we would be using a generation framework where you generate YAML file from Python, and you cannot generate the polymorphism, like YAML to support that uses polymorphism, you're kind of stuck. You have to fork the generation library so that you then add in the feature to support polymorphism, and then so that you can generate the end YAML file that the React generation tool can use. But in our case, we used validation, so we just put the polymorphism into YAML file, and that was it. Yeah, we didn't have validation, but on the other hand, everything else that was using the API could use polymorphism. And in that case, we just wrote the validation manually in our view code. So using the validation approach provides much greater escape hatches when you reach edge cases. And then finally, again in WCART, we had to rewrite, I think, 2 of our endpoints with Golang because we needed to get better performance and concurrency out of it. And if we would generate the YAML file from Python code, we would have to have like that Python code, that Python views, just so that we get the correct YAML file at the end that Go code could use. Yeah, and it's exactly the approach of using more cooling liquid. Don't just start writing code, bam, 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 done. Like really think what you're doing. So going back to the list of Python integrations for Swagger and removing those that are not written in the API first approach, I get down to these 5. 2 of those are done on top of Flask. Sorry, yeah, 3 are on top of Flask, and 2 are done on top of Pyramid. And since I prefer Pyramid, I get down to these 2. One has documentation in Japanese, which I can't use. And the other one sadly only supports Swagger, the old Swagger 2, not OpenAPI 3. So I was really left with one solution. So here it is. Luckily, I had Daemon available to me at that time, so we rolled up our sleeves and created a new package that integrates OpenAPI version 3 with Pyramid. It gives you documentation that is never out of date. With tried out examples, and also there's another benefit. When Pyramid starts up, we look at your specification and find if there are things that doesn't make sense. Maybe you're using references and the referenced item does not exist, so we will tell you. All the payload coming into your views is validated, so like this really decreased the code in our views because we don't have to do any validation in the views, and less code means less tests, means faster everything. And also the responses going out of our view codes are validated against the spec, so you're not sending out some data that you don't know you're sending, and maybe someone starts using, and then you realize that you're sending some data, and you fix it, and they go, hey, you destroyed the API for us. Give us back. So anything that is not in the spec cannot come out of your API. And it gives you, like for me, mostly I do code reviews, a single source of truth, which is fantastic. When I see a pull request, bunch of code changes, if the YAML file has no changes in that pull request, I know the API is not going to change, and I can ease off on the review. On the other hand, whenever I see the changes in YAML file, I know that our customers will be affected, our front-end team will be affected. I can really think about, are these changes necessary or what their impact is going to be. The package also comes with a couple of examples. One is this single file example, so the entire OpenAPI application in a single file. This is how it looks. It's a single endpoint called hello that, again, you can use the tried out examples to test and execute. It comes with tests that show you how validation works. In this case, if we don't provide a name parameter, we're going to get a nice missing required parameter name. And again, there's no code you need to write in your view. This is only come from the specification in the YAML file. Again, if the name is too short, the same thing. And also tests for making sure that if you send out responses that are not documented in the YAML file, the library won't allow you to do that. There's another example that implements a simple to-do app. So you see how posts work. And then finally, there's the real-world example. So if you go to realworld.io, you will see a collection of 1520 backends and 1520 frontends that implement a clone of medium.com. And then you can choose, for example, Django and Angular, or you can choose Flask and React, or something in Haskell and something in PureScript. And you can mix and match. And like this repository is fantastic when you're evaluating new technology for your next project, because you can see, okay, so how would a real-world app in Flask look like, or how would a real-world app in Django look like? Or if you're evaluating front ends, you can compare Angular and React side by side with real code. And in the end, you get an app like this, which looks exactly like Medium. You can try to sign up. You can sign up. You get some validation errors. And they provide a whole test suite that are basically exported Postman tests. And then basically, if you're doing a backend, you just have to make sure that all tests pass. And in which case, you can use any of the front ends, hook it up, and then it works. So obviously, there's a Pyramid OpenAPI backend now for a real-world I/O. And it comes with Pyramid with OpenAPI integration, Postgres for storage. Everything is ready to be deployed to Heroku in a minute. It has 100% test coverage, type hints, and a bunch of linters to make sure the code is well. So even if you don't plan to use Pyramid or OpenAPI, it's still a really good repository to look at to see how to write tests or how to use the new typing module in Python. And I've been using this repository as a scaffold for new projects for some time, and I know Matthew Wilkes also stole a couple of ideas from there. So I really encourage you, next time you have to do a microservice with the REST API, just fork this, change the YAML file, and then start playing with the models and views, and you can be done in a couple of hours. And remember, use more cooling liquid.
Thank you, Nejc. Any question? No? Yes. Here you are.
Okay, that maybe sounds now strange for you. I'm sorry about that. But I mean, of course, I have a question about documentation. I'm really sorry. How do you do reference documentation? Because for me, I'm more involved into documenting APIs. I still description fields and other things are only part of documentation for me. They are sometimes enough for developers, but not even for them always. So how you, for example, do reference documentation, if you do that at all?
Yeah, we do it with Swagger. So Swagger is not ideal for that, but you can put a lot of information into the YAML file that gets generated into HTML. Yeah, yes, because at least for us it's convenient because it's in the same place, and also if someone doesn't read the documentation but they open up the YAML file, they will see all the endpoints have documentation in there, in every endpoint in this YAML specification you can have description fields and whatnot. Yes, yes, I want to have a single source of truth because otherwise things can get outdated and then you have a problem.
I have one question about developing things, because if you say I'm writing the whole API as a contract-based idea first and then start to implement it, you said the whole system gives you a validation. So it says there are either options that are not available. So your API document says there is an endpoint for get your pets or something like that. And if you don't have it, does it actually starts really? Or is there a shortcut that you can say, okay, now I have all the endpoints specified, but there is a not implemented or something like that?
So at the moment, there is no system in place that will check if you've implemented a single endpoint or not. There's discussion whether we should add some checks like this, because now you can basically just serve the YAML file and the documentation will be generated and you can try to use it, but the responses will be responses will be basically 404. Okay. There is some people think that it would make sense to not even be able to start Pyramid if you haven't done all the implementation details, and maybe it's going to be a flag that you'll say please be strict or please don't be strict in the near future.